So I will hand over to Manuel Atug for his presentation on critical infrastructure and security and alike.
Okay, so here we go. Thank you for the invitation. I'm happy to speak to you all here, and I'm trying to explain a little bit about critical infrastructure security. And for that, I will introduce myself first of all, and then I will come back to critical infrastructure. What is this in Germany, and what is it about to make it safe and secure? And so what I'm doing is I'm head of business development, but this is more a title than the role I'm doing, because my topics are critical infrastructure security since many years. I started in critical infrastructure assessments, pen tests, and even audits or consultancy since somewhere in the 90s. So I was always involved in all this areas and production environments and the question of outage of critical things. And in addition to that, I started to interest in topics like hackback, which will interfere with critical infrastructure in the worst case, with ethics, how to be ethically correct in my own way, but how to ethically correct define the way how you try to operate and address critical infrastructures, or how you do pen testing, how you do search for vulnerabilities and how to communicate them, etc. And also one of the topics which came directly in relation to critical infrastructure is also the hybrid warfare. I hate the word cyber war because it's nonsense of PowerPoint guys who never have seen anything in reality. It sounds good, it smells good, it looks nice on the PowerPoint slides, but it has nothing to do with reality. There is no cyber war, and there will never be, because with only cyber you can never win a war. You have to use troops which will go into that other country and take care to take over everything. You cannot simply do that in cyber in the cyber area only. So you have a hybrid warfare, a mixed mode, and that is also an interest which I took care of since like 5, 6, 7 years ago, because I said this might be a problem, and it will be tricky for critical infrastructures. And unfortunately, Putin showed us how it looks like in his offensive war against Ukraine. But I was one of the people knowing about IT and OT in production environments and speaking about the risks of the cyber war, which was more a hybrid warfare topic. I also try to address cyber resilience, to say how can we make critical infrastructures more resilient to cyber attacks and cyber attack scenarios. And all of them together resulted in that I saw different critical infrastructures where I said, oh my gosh, what is this? I might prepare myself for outages in my private spare time as a civilist, and therefore I came to the topic civil protection. How does this work? And also how does the cyber area and the civil protection combine to each other? Yeah, in fact, it doesn't combine very much, but we're trying to get this together. And for that, I founded also with some others the AG Kritis, which is an independent interest group to make sure that critical infrastructures are safe and secure and still work. Or if there is a case of a cyber-physical attack and we have a big outage, how to fix this. And that is what we are doing in our free time as volunteers in the AG Kritis. So that is what I'm doing, and mainly I'm ranting at Twitter with my nickname Honkhase about critical infrastructures which are not safe and secure, or people who did mysterious stuff with them, like ransomware attackers, or even this all cyber war jumba wamba guys, or people who like hackback. So let's get back to the topic. So I know a bit about my background and can better understand what I'm speaking about, from which point of view. And in case of any question, please, with sugar on top, just ask, and I can discuss these topics for you too. So what is critical infrastructure, or Kritis in Germany? And we have an official definition of critical infrastructure in Germany, which is defined by the Bundesamt für Bevölkerungsschutz und Katastrophenhilfe, the civil protection organization in the government. And they say critical infrastructures are like organizational and physical structures, facilities, etc., which are of such vital importance that the whole nation's society and economy might, if there is a failure or degradation, result in sustained supply shortages, and there might be significant disruption of public safety and security, or even other dramatic consequences, which are in the similar case, like supply shortages which are huge, or the disruption of public safety and security, which might also result in dead people. So that is what the definition is of what is a critical infrastructure in Germany. And we have defined 10 different sectors which contain all the branches in there which are critical in Germany. And we had from the European NIS directive, there was a request that this directive has to be implemented in all the European countries. And Germany did this with the IT security law in 2015 and founded 9 different sectors, which start, for example, here with energy, health, environments, information technology and telecommunication, transport and traffic, media and culture, water, finance and insurance, food, and state and administration. And last year was the update of the IT security law. There was an IT security law 2.0. There was a municipal waste management, which came in top of it. So we have altogether 10 critical infrastructure sectors in Germany, which are declared as critical infrastructure. State and admission is a little bit different colored, because this is, for example, not regulated in the BSI, the German security organization in the government, because this regulates all the different areas, but state and administration is different because the BSI is not independent. It belongs to the Innenministerium, the Ministry of Interior, and therefore it's not independent, and an independent organization can't force the state or administration to do something. So there is no direct request for state administration that they have to do some kind of security. But for the others, there is this IT security law, which got several paragraphs in the BSI law, and in the connected BSI, how's it called in English? I don't know. BSI Kritis Verordnung. It's directly related to the law, but it defines all the scope, environment, and what exactly has to be done. But it is legal binded by the BSI law. So this is what we are speaking about. Some people say this is not sufficient. For example, you might think about chemical industry, which is not mentioned here. There are, of course, some discrepancies in the United States, for example. We have 16 different sectors, but they also split sometimes things which are consolidated here, like finance and insurance. We say this is one sector, and in the States they have sometimes the separate sectors for all this. So that is in general what we are speaking about when I say critical infrastructure in Germany. And what's the main idea behind defining critical infrastructures and addressing them is that you want primarily to protect the population and not the operator of the critical infrastructure. Because a water production facility, for example, if they have an outage and it costs them 10 million, like no one cares. It's their own business risk. But if they have an outage and people cannot get water anymore, and there are like 2 million people involved in this loss of water, then it is very important to make sure that the water is up and running again, that people get their water and don't get into serious and huge problems. So it is really the point of protecting the population. And very often it contains identical components. If you look like on industrial control systems, you have the relay components, SCADA components, etc. Usually you don't have too many vendors who are producing such components. And of course, every single production facility is really very individual and has its own story of history. But in overall, you can say there is somehow identical components which are used, which also makes it more risky. And the more we are doing the digitalization, the more there will be also some kind of standards and standardized components or approaches and processes, which means that the cascading effect of an outage will get more and more into the risk map. Yeah, and by digitalization, this doesn't limit with connection to the internet. More and more components which haven't been designed to be connected on the internet are now connected to the internet or will be connected in the next years. So we have also some kind of digitalization in this way. So attackers have more attack vectors through the internet to gain some kind of access or initial access to the critical infrastructure environments, and by this might be able with lateral movement to get more privileged, more different systems and compromise everything, and maybe outage even the production environment. And operational technology, OT, is in operation for decades. So this means also it's not like you have, I don't know, a Windows operating system which is used like 5 years, or you have a laptop and you use this 3 or 5 years in operational technology. You have a production facility which was built up, and everything is approved and fine and up and running, and you don't want to touch it if you really don't must do it. And by this, production facilities are running for decades. I've seen a pump in a water production facility which was 70 years old, not 17 but 70, and 70-year-old pump which was huge and still running, like built up before a week. I would say it will even run another 70 years because it was indestroyable build, good old work. And they did put, of course, some kind of field sensors around the pump to make more, to reduce the field service technician time, that it comes every month and checks for it. But they can check by the field components sensors if everything is fine, and if the field service technician might come in 6 months or 8 months or whatever. So of course, there's also some kind of digitalization in this OT components around them, not in their main part, for example. But as I said, they are running for decades and will be still running for decades. And that means that they are also a risk, of course, from this long time frames to think about how to exchange something. And when we move over to the cyberspace, well, the cyberspace results in risks for everyone, because there is one cyberspace for all the actors in there, which means we can start like state actors, we have military in there, we have cyber espionage, so we have all the secret services, etc. in there, we have critical infrastructure in there, state and administration, of course, as one of the critical infrastructure. We have the civilization in there. We have hackers and nerds in there. We have the how is it called in English? Wissenschaft und Forschung, research and development. So research and development is also in there, and we have also maybe young guys which are ethically not that stabilized, but want to hack and destroy maybe things or break into environments. So the cyberspace is one space for everyone, and everyone worldwide. It's not only limited to a street or a city or maybe even a country, but it's worldwide for everyone. And that results, of course, in the risk for everyone, because everything can happen in this one cyberspace for all. And that is an important thing you have to remember of. It's a much more complex environment than speaking about a physical production facility on one environment or area, or that's a big difference. And being Kritis results usually in higher risks because, well, you have, of course, some kind of interest because it is critical infrastructure. It might be, for example, interesting for the actors which I didn't mention especially, but cybercrime actors which do ransomware attacks, for example. So being Kritis results in higher risks because you are a high-risk target. So higher risks are higher. Well, how high are they? Let's see. Supply chain attacks, for example, are also a problem which can interfere with critical infrastructures. And we had, well, it's a cyber attack to a company by exploiting the vulnerabilities which their service providers had, or managed service providers, or remote access components which are operated. And we had, for example, the Kaseya supply chain attack. This is an IT management and monitoring software. And SolarWinds, for example, was another one where they did break into SolarWinds, and by this managed to get in many critical infrastructures because they were customers of SolarWinds. And ransomware, I did mention this, for example, already. Emotet was a very well-known quite a long time, but now the cyber attacks, which by encrypting the victim's data and threaten to publish that data and get some ransom paid, by paying the ransom, you can unlock or decrypt the data and start the production again, or you prevent that the data is published. And well, Emotet was one of the well-known beginnings, but then there was WannaCry, NotPetya, Ryuk, Grand Crab, Maze, Conti, Revil, Doppelpaymer. There are many groups out there now because they are doing currently more than several $100 million per year. And the thing is, if they make all this several $100 million per year, this is brutto as netto because they don't pay taxes. So this is a very intrinsic motivation for such organized crime groups to say, we want to make more, or new groups forming to one of the ransomware groups and saying, we want to have some part of this business. And they really operate like business companies. So it is really a professionalized sector and a gray market or a dark market, which really works like official markets. So this is a big risk for critical infrastructures because, of course, they can very good compromise such environments, encrypt everything, and the production is broken or reduced. And that is, of course, a big risk, and therefore the people are more motivated to pay the ransom. Yeah. So this is what it looks like, and what the whole cyberspace defines. And let's have a look at cyber-physical attacks, which are also risk, not only encrypting data, but there are also cyber-physical attacks possible. And I just picked up the 5, let's say, best and well-known sophisticated industrial control system attacks to see how this looks like. In 2010, I guess many of you know Stuxnet, which was an attack on the Iranian nuclear program, which was efficient, efficient maybe not, but it worked. It worked, and it was 100% successful. Because in Natanz, the centrifugal components were broken after the malware was executed on site. But it was a huge effort to get American services, the Israeli services, many years to many different versions of Stuxnet to develop it. And after years, they got through the Netherlands services in one espionage guy with a USB stick on site, and he put the stick in and started the malware because it was an air-gapped, separated environment. You had to bring someone in. So it was a lot of efforts but at the end it was effective because it worked. And well, in 2013 we had HAVEX, which was a remote industrial espionage access software for ICS and SCADA components, which worked somehow, but it was not too much and too many attacks which were successful. Then we had 2015 Black Energy, which was an attack on the Ukrainian power grid, mainly manually approached, and Industroyer 2016 was again an attack on the Ukrainian power grid, but this was more an automated approach. So they did much more automatization into the malware, but nevertheless, there was an outage of like 1,230,000 people had no power in the winter in December for around about an hour. And what they wanted to do 2 times was creating a blackout. But it didn't work. So like HAVEX, this was more like, well, they tried but didn't made it. And 2017, we had Triton, which attacked SES level 3, SIL level 3 safety instrumented system from Schneider, the Triconex component. And that was an attack on a Saudi petrochemical plant, but this attack was really sophisticated, but still it didn't work. They had problems in executing the attack, and it simply the guys on site took care, and it was even some kind of a failed attack, but very sophisticated. So we see the development is there, the attackers are there, the malware is there, but at the end, there's only one really proof of concept example, which you can refer to, Stuxnet. This might be changing in the future, but at the end, time will tell us. With more digitalization, it will be the case, I guess, but we will see. So, as I said, higher risks are higher. So threats become bigger. We have the cyber warfare or the information warfare, hybrid warfare. You can name it as you want, but cyber warfare is a generic definition of it. We have very professionalized cybercrime, and we have organized crime methodology implemented now in the cyberspace. We have IT dependency, like on the supply chains, which is a risk, and we have digitalization and globalization, which gets more and more into complexity, into problematics, and we have an IPification of all the things. So things get now an IP interface, which were never designed to speak IP, and it gets worse and worse. So I would say, there are some, or there shall be some positive news, but well, maybe the next speakers will tell about. I don't have to. I have no positive news for you. It looks really bad, yeah. But what we can do is to say what is the approach to make it safe and secure. And one of the most important things is the curse of competence. Yeah, competence will interfere with breaking things. And very important is to always think about resilience and fallbacks. So you should sometimes ask yourself about your environment or your component where you're responsible to. Do you all know how you would do the process with pen and paper? So if all the IT support is lost completely, ransomware, or even with a climate catastrophe, everything is underwater or whatever, are you able to do your processes with pen and paper, yes or no? For the production, it is tricky, but with pen and paper to use the machines, configure them in the right way, and operate and produce still your parts, it might be possible with pen and paper. The question is, if it's possible, do you know how to do it? So that is really the main topic, to say that can raise resilience and provide fallbacks as alternative approaches to get a stabilized approach. So we can do some kind of happy, joy scenarios and enhance security. But very important is cyber resilience is key to success, as I told you now. And defensive is much more efficient instead of offensive, because in the defensive, you put the basic security settings or safety and security settings into the environment, into the processes, into the production facility. And by this, you make it safe and secure. You don't do offensive approaches like hackback, like cyber war scenarios, like keeping vulnerabilities back to use them on foreign states. That doesn't enhance really the security. But if you maintain your firewall on a daily basis, if you operate the identity management in a proper way on a day-to-day basis, you have a continuous process of making and living security, and that is exactly how security and safety provide some kind of resilience. Yeah. What also is very helpful is a positive error culture. You should speak about errors, you should speak about problems, and you should be able to mention that without someone from the management saying, cannot say that we are insecure in this way, we don't accept such an announcement or whatever. So you need really a positive error culture to find ways how to get rid of these errors and to speak about the problems. And with this, of course, reporting, discussing, and exchanging with each other comes together, and that is really also a very important task to be done. Use and incorporate feedbacks is very helpful. So by this, you can get some kind of exchange and learn from each other, and put the feedback again in the processes and approaches. And you should use feedback channels and learn from them. So actively using them, actively learning from them gets the processes and approaches in the production facility also more and more into some kind of resilience, because you learned already from problems and found solutions for it without having the problem. So that is the most beneficial approach. And if I say we should speak and communicate, this means that you should always remember that IT security is not a one-man show. So all together have to do this, and everyone, really everyone, is also only cooking with hot water. There's no silver bullet, magic silver bullet or whatever available. And by this, you can stay together, stay strong together by discussing the points and having a very efficient feedback to each other. And together you can see more than someone individually can see. So 4 eyes are better than 2 eyes, and that's also a policy which works very good in the IT security and safety of such environments. And of course, working hand in hand all together is also very helpful because processes are usually from this person to this person to this person and results in that person. And if all of them work together, you can also take care of the interfaces of each other and take over in the right way what you have to take care of to make it safe and secure. So working hand in hand together is really one of the keys. And a different definition of IT security is not a one-man show. You should know and use your information security management system and your business continuity management, because at the end, you can operate security by saying, hey, it's a technical problem, I can address it technically. Or you can say it's an organizational problem and I do organizational processes and procedures on it. But at the end, you will need both. You need technical and organizational solutions, because for the technical implementation of things, you need an organizational approach to make it a process which is done every day, like 24/7, the whole year. And this can only be done if you have organizational processes for the technical implementation of things. But only having organizational processes without the technical realization is also, of course, not very helpful. But both together as an ISMS and a business continuity management, where you know what to do when an outage happens to get the impact very low, or if there is an impact, to address it quickly. And that is exactly what, for example, in Ukraine happened when they had this outage in 2015-16. They took care and immediately reacted, and after an hour the attack was completely gone, because they took control of everything. They got all the power outages under control. Power was stabilized again, and there was just this 1 hour for 230,000 people instead of a whole blackout of the whole country for many days or even weeks. So having a business continuity management with fallback approaches, manual processes, pen and paper approaches is really key to success, to make sure that the critical infrastructure and the critical services which they are providing are really working in a proper way. And yeah, as the last one, did I already mention the positive error culture? It's really, really, really important, because you have to speak free about problems. You can do trainings about such scenarios to address them properly. But if everyone knows this is the single point of failure and everyone looks away and says, I don't care, or if I mention this, they will cry and yell at me. I'm not interested. I'm not telling it to anyone. But if then an attacker or a risk is addressing exactly this error, and afterwards everyone says like, yeah, I did know that this would happen, that's not really helpful. So please, please, please take care of such things, and remember that these are the approaches which are helpful to build some kind of cyber resilience and take care as a whole topic to make it in organizational approaches and technical detail implementations. Last but not least, what do I do when all else fails? I thought about this very long, and finally I came to my own conclusion. Many people said something with wood, and I said, nah, I'm going to be coconut picker. If everything, if everything is destroyed, I have to get rid of power and IP or internet. And I would become a coconut picker on an island, live over there without IP and IT. So you have to choose what your exit strategy is. I have my one, and said I don't come into my exit strategy. I'm taking care, like having these lessons or explanations and speaks to explain what it is about, to make sure that I don't become a coconut picker. So thank you very much.